In the first lesson on rational expressions, we looked at the definition, we looked at excluding from the domain and simplifying rational expressions. The second part was multiplying and dividing rational expressions. And now we're going to look at part 3, where we're adding and subtracting rational expressions. We're going to start with having the same denominator, and then we'll start looking at what happens when the denominators are different, okay? And you're going to see that in this lesson, most of the examples use subtraction, just because subtraction is a little bit harder, so I want to make sure that you're being careful with all the parts, all the steps of subtracting, okay? So just like with a rational number, when we add or subtract, the denominator stays the same, and we add or subtract the numerators. Okay, so here the two denominators are the same. All we're doing is subtracting our numerators. Excuse me, my pen is not working here. Let me try that once more. So the denominator will stay the same, x squared plus 5x plus 6, and my numerator becomes 6x minus 2, and I'm subtracting the entire thing. So use your polynomial subtraction skills here as you do this. So we've got x squared plus 5x plus 6. And we've got 6x, we're subtracting 5x, so we've got 1x, or just write it as an x. And we've got negative 2 minus negative 5, so that's really like adding 5, so we've got x plus 3. So because the denominator could possibly be factored, let's factor it to see if we can simplify at all. So our numerator is x plus 3. Our denominator will be x plus 3 times x plus 2. And sure enough, we can simplify the x plus 3's. So we're left with, keep in mind, when you divide a factor by itself, we end up with a 1. So it's 1 over x plus 2. And let's look at what we need to exclude from our domain. If you look at the factored version of our denominator, we can see that x cannot be equal to negative 2 or negative 3. So fairly straightforward when we are adding or subtracting with the same denominator. So feel free to press pause, try this one on your own, and then press play again. So here my denominator is the same, so I'm going to just keep it the same, and I'm going to combine my numerator. So it'll be x minus 3x plus 2. So that gives me an x minus 3x, so that's a negative 2x, and minus 2 all over x plus 1. It looks like we might be finished, but I'm noticing that there are two 2's here, and actually both of those terms are negative. So what if I common factor a negative 2 out of the numerator? I'll have negative 2 times x plus 1 all over x plus 1. So notice that those x plus 1's now simplify, and we're left with negative 2. So this whole expression is negative 2. Now let's take a look at what happens when the denominators are different. So again, here there are a couple of different cases. The first one is when the denominators don't have anything in common. And a nice example of that would be like 3 over 7 plus 1 over 6. 7 and 6 don't have any factors in common. And if we look at that, we would go, well, 7 times 6 is going to be our lowest common denominator, which is 42. So that means we need to multiply the first term by 6, and we're going to multiply the second factor or fraction by 7. So we really will end up with, as 42 is our denominator, we'll end up with a 3 times 6 plus a 1 times 7. So 18 and 7 is 25 over 42. Okay, because really when there's nothing in common, you can just multiply this, the 3 by the 6, the 1 by the 7, add those together, and multiply to get our denominators. So a rule of thumb would be A over B plus C over D equals A times D plus B times C all over B times D. And that works beautifully as a nice rule, so long as, oops, B and D don't equal 0. Just write that a little better. B can't be equal to 0. D can't be equal to 0. So remember, this nice quick method only works if the denominators do not have any common factors. Okay, so if you look at question D here, everything is in factored form already. So you can see that the denominators don't have any common factors. So that means our new denominator will be, think of this as our A, this is the B, this is the C, and this is the D. So our denominator will be B times D. So 2x minus 3 times x plus 3. And our numerator will be x plus 2 times x plus 3. A times D. And now here, instead of adding, we're subtracting. Minus BC. So I'm going to put the C first just because that's what we do. Times 2x minus 3. Now let me make sure I extend that horizontal line a little neater there. Let me just clean it up a little bit. 6 plus 3. There. Okay, so now I need to clean up my numerator. So to do that, I'm going to use the distributive property and multiply through. Take your time with this and press pause and do it and see if you get the same result I do. When I multiply these two, I'm going to end up with x squared plus 5x plus 6 minus 8x plus 12, because it's negative 4 times negative 3. My denominator, I'm going to leave it in factored form, 2x minus 3 times x plus 3. So I could clean up the numerator a little further. I've got an x squared term plus 5x minus 8x, so that'll be minus 3x plus 6 plus 12 is plus 18, all over 2x minus 3 times x plus 3. Now that numerator looks like it might factor. So if it does, it'll be factoring by inspection. So I need two numbers that multiply to give me 18, add to give me negative 3, and I think negative 6 and positive 3 will work with that. Let me just scroll here and give myself a little more space. So I'm going to have x minus 6, x plus 3, all over the denominator still the same, 2x minus 3 times x plus 3, and lo and behold, I can factor out those x plus 3's. So I'm left with x minus 6 all over 2x minus 3. And let's look at our denominator before we simplify it and decide what are the values of x that need to be excluded. If I look at 2x minus 3, I can see that x cannot be equal to 3/2. And if I look at the x plus 3, I can see that x cannot be equal to negative 3. And that subtraction question is finished. So now let's take a look at what happens if there are common factors when we're adding or subtracting. Keep in mind that we're following the same rules as we do for fractions, so we want lowest common denominator, which is also sometimes called the least common multiple. So when we add or subtract, we find the lowest common denominator. We multiply numerators and denominators by the same factors so that both fractions have the same lowest common denominator. And then we add or subtract the numerators and the denominator stays the same. And we simplify if possible. So now here though, because they're rational expressions, we need to find the lowest common denominator. And it's a little trickier than with numbers, but really, if you think about how numbers work and how the factors of numbers work, you'll see that it really is very similar. So to get the lowest common denominator, we're going to completely factor both denominators. And then the lowest common denominator will be all of the factors of the first denominator and any extras from the second one. Okay, so I'll explain that with this example. So here we've got 3 over x squared plus 6x and 7 over x squared plus 8x plus 12. So yes, plus 12. So we're going to look at how to find the common denominator for that. So if I look at x squared plus 6x and factor that, this one becomes 3 over x. There's an x in common here. So we're common factoring x plus 6. Okay, so the two factors are x and x plus 6. And in the second one, I've got 7 over x. Let's see, I've got two numbers that multiply to 12, add to 8, so that'll be an x plus 6 and x plus 2. Okay, so our lowest common denominator is all of the factors of the first fraction. So that's our x and our x plus 6. And then any extras, any new ones. So the x plus 6 we've already taken care of, but the x plus 2 is the extra one. Okay, so that's the lowest common denominator for those two rational expressions. So when we're adding or subtracting, the first step is to find the lowest common denominator, and then we multiply tops and bottoms, numerators and denominators by the same things so that we get that lowest common denominator, and then we can add and subtract our numerators. So let's do a couple of examples. I've got x plus 3 over x squared plus x minus 2 plus 2 over x squared minus 1. So let's factor these denominators. So I've got x plus 3 over, and now we're going to use inspection. I want two numbers that multiply to negative 2 and add to 1. So that would be a positive 2 and a negative 1. So x plus 2, x minus 1, plus 2 over, and I've got difference of squares there, x plus 1, x minus 1. So we'll just write what our lowest common denominator is off to the side here. It's all of the factors of the first one, so x plus 2, x minus 1, and any new ones that are different on the second one. So it's just going to be the x plus 1. Okay, so that's our lowest common denominator. So for this first fraction, to get it having this as its denominator, we already have the first two factors. We just need to multiply the denominator by x plus 1. If we multiply the denominator by x plus 1, we also multiply the numerator. So we end up with x plus 3 over x plus 2 times x minus 1 times x plus 1, because I'm multiplying the denominator by x plus 1, so I'm multiplying the numerator by x plus 1 as well. This fraction is the same as this fraction, but I've multiplied numerator and denominator by the same thing so that I can get the lowest common denominator. Now, to simplify things with writing, I'm going to just extend this, and I'm going to look at my second fraction now. To get this same denominator, I've got the x minus 1 and the x plus 1, but I don't have the x plus 2. So I need to multiply the denominator by x plus 2 to get it over this. So now I'm going to multiply the top by x plus 2 as well. Okay, So now I've got common denominators, so I can now multiply in the numerator. I'm going to just multiply through those brackets and simplify. So using the distributive property, I'm going to have x squared plus 4x plus 3 from the first two multiplications there, plus 2x plus 4, all over x plus 2, x minus 1, x plus 1. So if you look at the numerator, and we'll just collect our like terms, I've got x squared plus 6x plus 7. Oops. All over x plus 2, x minus 1, x plus 1. We could look at the numerator and see if it factors. It looks almost like it would because I've got 7 at the end, which I could get there multiplying by 1 and 7, but that wouldn't give me a positive 6. They'd have to both be positive or both be negative to multiply to 7, and I can't, with them both positive or both negative, get a 6x as my middle term. So this is simplified as far as it will go. Let's do one more of these. It takes a fair bit of writing, and you really have to kind of stay on top of things as you're doing them. If you feel confident in doing this, try the next one on your own by pressing pause and then pressing play again to see how you're doing with it. Okay, here I'm subtracting, and I want to be careful here to factor first because I want to find my lowest common denominator. So I've got x plus 5 over x plus 2 times x minus 2. Notice that I'm not pausing here too much to do the factoring. Factoring needs to be fairly strong skill at this point. And I'm subtracting x plus 1. This one, the denominator doesn't factor any further, x minus 2. So our lowest common denominator is going to be both factors from the first fraction, so a rational expression, x plus 2 times x minus 2, and any that are missing from the second one. Notice that the second one doesn't have anything new, so this is the lowest common denominator. So that means our first fraction here, our first rational expression, is not going to change at all. Our denominator will be x plus 2 times x minus 2. Our numerator is x plus 5. And now we're subtracting. And we've got, on the second fraction, we need an x plus 2 in the denominator. So we need to put it in the numerator as well. So we've got x plus 1 times x plus 2. So now let's clean up the numerator. We have x plus 5, and we're subtracting. And I'm going to just put a set of square brackets here so that we remember to subtract everything. And I'm going to multiply through these brackets here on the x plus 1 times the x plus 2. So I have x squared plus 3x plus 2. And my denominator is x plus 2, x minus 2. It's really helpful to leave lots of white space on your page when you're working on these questions so that the lines don't run into each other. So I've got an x plus 5 minus x squared minus 3x minus 2. So let's do that subtraction. So I've got a negative x squared. I've got x minus 3x minus 2x. And I have a 5 minus 2, which is a plus 3. All over x plus 2 times x minus 2. And we're finished. Again, lots of writing for these. Very important to keep track of where your denominators are. And that's it for adding and subtracting rational expressions. There'll be lots to practice in class. There is going to be a short lesson on complex rational expressions that I would like all students who are confident with this material to try because it's a really good skill to have.